Okay, we are doing a lab today, but before we can do the lab, we're a little behind. Part of it's my fault. But this won't take us too long to go through. Okay, so 1 through 4, we went through the discussion on the board. I have some equations labeled and I have some values indicated. You can either take it off your notes or take it off of the board. So we're doing the worksheet here: chemistry, pressure, and volume. That's what we studied. That's what we studied yesterday and the day before with the syringe. We pushed it in, it created more pressure. We pulled it out, it created less pressure. Okay, and so bigger volume, lower pressure. Lesser volume, more pressure. And we talked about that, and we're going to continue to talk about that here. I expect you to at least fill some of that out. If you're waiting for me to give the answers, then you're not really learning a whole lot. Okay? You should be able, from our discussion a couple days ago, look up here and you can glean 1 or 2 units for force. They're right up there. Okay? Not a symbol for force. That's an F. That's a symbol that represents force in an equation. That's not a unit. What are 2 units for area? It won't be an A. That's not a unit. Okay? You have 3 units of pressure. Different units, like different numbers or different values. And we use all 3 values just because of different reasons. And then the definition of pressure really is rewriting this statement right here. Okay, rewriting that statement. Okay, so it's just rewriting this in a word, in a written sentence. All you're doing is rewriting what that is in a written statement. If you get done with 1 through 4, then I'd like you to do number 5. And number 5 is pretty self-explanatory what you need to do. So today we're going to investigate temperature and pressure. And before you guys left, so at a location, you guys will need to get a pressure probe like you did, but then you also should have some tubing in that pressure box that will go into a 125 milliliter flask. Okay? Now, that'll be down here in a basket. You should have a basket. You can pull out. It gives you 125. Right there's a nice, clean, pretty new one. And it fits in like so. Okay? This will go into your pressure sensor. Okay? And then you'll also get a temperature probe that you're going to hook in as well, so you can read both pressure and temperature at the same time. And these are the temperature probes. Okay? That you'll get. And you will have 4 different temperatures in which you will go. Okay? There's ice in this bucket. We'll have it up front. You're going to put ice in this middle. There's a middle trough. You're going to put ice in there. So you have ice water. You have a 400 milliliter beaker that you're going to fill up to the 300 milliliter mark with just regular water. Okay? Then up front I'll have some hot water that you're going to pour, it'll say the directions to pour out about half of that and fill in with some hot water. And then this is the boiling water you're going to put it in when you're boiling. Okay? Okay? So The directions are pretty self-explanatory. So let's go through this. What are 2 units for force? Pounds and newtons. What do we use? Well, you actually use pounds, but in this class we will use newtons. Okay? What are 2 units for area? Yeah. Inches squared and meters squared. That doesn't mean that's the only 2 units possible. Okay? Get 3 units for pressure. They're right here. 101, or you can just put kPa, millimeters of mercury, and ATM. All of those. So where do you get this reading, 760 millimeters of mercury? Where would you find that? What instrument measures this? Barometer. Okay? Barometer measures this. Okay? And then from the barometer we can get these other 2 readings by converting. We'll do some converting probably starting on Monday. Not too difficult to do. So the next part, what you're going to do is you're going to go ahead and draw 2 boxes. Okay? And you're going to fill them up with 10 each. You can do circles, you can do whatever you want, but those 2 boxes, and you're going to fill in 10 molecules each. So go ahead and do that for 5A. Just go ahead and draw 2 boxes, one about half the size of the other. Okay? You could do a cylinder shape as well. It's up to you what you want to do. Alright, questions on that? So we're going to look at B. It says, if the pressure in the 10 milliliter sample, this would be the 10 milliliter sample, okay? And this is the 5 milliliter sample. It says if the pressure in the 10 milliliter sample is 2 atmospheres of pressure. And then you push down the cylinder so it takes up that amount of space over here. What would be the new pressure? What would it be?
1 ounce.
No. Now you guys know the relationship, right? So the volume is doing what? It's going from 10 to 5, and we would say that's cut in half. If that's cut in half, the pressure needs to do what? Double. It's an inverse relationship, so it should be what? 4. Does that make sense? Now if you look inside here, these are colliding with the size of the container. How does the right side have more collisions per time, or does the left side have more collisions? The right. It has double the collisions because it's half the space. If it has half the space, we got double the collisions. Okay? You don't have to do this part, but let's say that we do this, and now it goes to 2.5 milliliters, and we have all those in there. Again, you don't have to do that. What's the pressure inside that one? 8. Good. Okay, so that is, so what we're going to do, we're going to find a constant. So you guys remember, did we multiply volume by pressure to get the constant, or did we divide pressure or volume by pressure to get the constant? Which one did we do? Multiply or divide? Multiply, we did. So if I take 2 atmosphere times 10 milliliters, I get what? 20. If I take 4 times 5 milliliters, what do I get? 20. What would I get there for 8 and 2.5? 20. So when you guys did your experiment, the more constant it was when you took the pressure times the temperature, the better values you got. So I think a lot of you got around 1,000 is what you did when you took the pressure times your volume. And that's Boyle's law. So I'm going to give you, turn it over to the back, and we're just going to do one of these problems because that's what I did yesterday with the class. So I'm going to give you the equation. We'll define Boyle's law later, okay? But I'm going to go ahead and show you the equation for Boyle's law. It says P1 times V1. That means an initial pressure and an initial volume of a sample. Then P2 times V2 would equal what it would be after you do something with the volume and change it. So this could be initial and final. Sometimes people like to go PI times VI equals PF, VF. This would be initial, and that would be final. Okay? So, but in number 8, I'm using this here in which to do it. So, what I like to do is look to see what I need to solve for. V2 is what I'm solving for up here. So I'm not going to put any numbers in until I have to. So, could you, on your paper, let's see if you can do it, I want you to go ahead and get V2 by itself. What does V2 equal when it comes to the other 3 variables? So on this side, what you're going to have to do is with just the variables and not the numbers, just go ahead and solve for what V2 equals using your algebraic skills. Solve for V2. Everybody in here can do this one. Okay? It's just one simple step you have to do and then you solve for it. So V2 equals what? What's on the other side multiplied on the other side? P1 times V1?
Minus P2.
Not minus.
Divided by.
Divided by. Okay, because we're multiplying, so we don't. If you're adding, that would be something you could do. So it would be P1 times V1 over P2. Go ahead and solve for that. So go ahead and just plug your numbers in for your different variables so you can solve for the final volume, you can call it. Okay? So go ahead and do that. You're plugging in the numbers for number 8. So number 8, you're plugging in those numbers. So it would be P1 times V1 over P2. So now all I have to do is just plug in those same numbers. It represents those symbols. What's happening to the pressure? Is it increasing or decreasing? P1 to P2. So it's going from 4.4 to 1.3. Okay? This is about a third. Not quite a third. 1.3 will fit into that about a little over 3 times. So what should my volume be? Should it be increased by 3 or decreased by to 1/3? What do you think? So is the volume going to go up or down when the pressure goes down? The volume should go up. So I should have a number in here that's about 3 times bigger than the 4.4. Who has an answer for that? You got it?
11.5.
What is it?
11.5.
So it's 11.5 liters. So if the pressure goes down, the volume's going to go up the opposite way. Okay. You guys can put that away for now, because we'll look at that tomorrow. Okay? We'll pull that out at the beginning of tomorrow. Okay, guys, the labs. I know yesterday was a day that I wasn't very organized and I didn't have things up here like I should have when I was showing you what it should look like. But